The Sun releases a lot of CMEs. Most are nowhere near large enough to cause any problems. But there are varying levels of geomagnetic storms that can occur from those eruptions. The fast-moving cloud of particles from a CME can often be seen coming out of every part of the central blocking disk on the Soho-Lascaux C3. We call it a halo eruption, and it is a good indicator that the CME is heading in Earth's direction, an Earth-directed CME. These CMEs are known at the Earth level as an interplanetary shock wave. Earth's magnetosphere is our protective shield against these eruptions, and in all but the largest blasts, you really wouldn't notice any difference, unless you live at high latitude and can see the auroral effect of geomagnetic storms. The level of the storm, the effect on satellites and electrical grids, is largely dependent on the density and speed of the CME. The stronger the solar flare, the stronger the solar wind effect. And the stronger the solar wind effect, the stronger the geomagnetic storm. The National Oceanic and Atmospheric Administration Space Weather Group rates storms based on the energetic changes and magnetic disruption to Earth's magnetosphere. The lowest level events mostly just cause auroras, although migratory animals dependent on Earth's magnetic poles for navigation may also be affected. The stronger the storm, the larger the effect. Satellites, spacecraft, transformers, and power grids, they become vulnerable to these events when the storms reach their highest levels. Humans have seen numerous level 5 events, but nothing like a repeat of the Carrington event we saw in Chapter 6, at least not since we became so dependent on electricity. Scientists are discovering how these and other space weather events subtly affect the atmosphere and the oceans, and even things as relevant to our lives as lightning and earthquakes.